Hi, this is Kumaran. In this video, we will discuss about the subtraction of two 8-bit numbers. In the series of Programming 85, this is the third one. We'll start this subtraction. So you know that binary subtraction is a tricky one compared to that addition, because binary subtraction we have, even though we have a subtractor, but how it is happen in microprocessor is a little bit tricky. That words we will discuss before the program. 25 minus 35, that is what we assumed. The data is available on the memory, 25 and 35. These two are hexadecimal numbers, not the binary decimal number. So 25H and 35H. So let's do this in binary calculation, how the binary subtraction is happening in microprocessor. So even though the 25 minus 35 means the processor will not perform subtraction, it will perform addition as 25 plus of minus 35. So you know that to represent a negative number in binary is a 2's complement method. So we will take 2's complement. So for that, first we will write that what is 35 in binary. 35 means it is 0 0 1 1 is 3, then 5 is 0 1 0 1. This is 35. 2's complement direct method is look from LSB up to first logic 1 you copy. In this case, the data is available on the first number itself. So you take 1 here, remaining complement everything. So this is minus 35. So now we have to add with 25. So 25 binary number. 25 is 0 0 1 0 is 2. Then 5 is 0 1 0 1. You add this both. So addition only with this. 1 plus 1 is 1 0 0 here. Then again it is 1 0 1 0 1 0. Here it is carry 1. It is becomes 1 1 1 1. The actual carry is 0. We have to complement, it becomes 1, because this is the part of the 2's complement addition process. Even carry you getting 1, you have to complement it back to 0. So what answer you are getting? This is F0. Okay, F0 is your answer, but actually is it your answer? 25 minus 35 means minus 10 you have to get. That's your answer, but we are getting F0, which is equal to that minus 10, which is negative 10. So answer is in negative form. You take 2's complement, take look from LSB up to first logic 1, you copy everything. So here logic 1 appears only on this digit, so you copy all the digits as up to logic 1. Then complement remaining bits. So here it is 0 0 0. The carry flag, it's a borrow, you should not take here. So here the answer is 10 you are getting. So this is what binary subtraction. But look at this here. In microprocessor, all these steps will be done for the instruction sub. The entire process for sub. Whenever you write an instruction sub, the processor will do all these steps. So you will get carry flag 1. Then we have to take externally 2's complement out of the instruction. So this process not included in the subtract. So we have to take, because suppose you do the reverse, you won't get complemented carry as 1. So that also will do. 35 minus 25 will do. 35 first you will take 25. For that you will take 2's complement. 25 is 0 1 0 0 1 0 is 2. 5 is 0 1 0 1. So minus 25 is to take 2's complement, first logic 1, remaining complement, this is 25 minus 25, then 35 is 0 0 1 1, 5 is 0 1 0 1. So add both, only this. So add 1 plus 1 is 0 0 0, here also 0, then 1 here, triple 1 is 1 1, we keep 1 here, 1 1 is 0 0 0, carry 1. So as per the 2's complement addition process, you complement this, it becomes 0. So what you are getting here is 0 0 0 1 is 1, all zeros are 0. So directly 1 0 as answer we are getting, because larger minus smaller, 35 minus 25. So here the borrow will not be 1, it's a 0, but actually this one, as per the instruction, it will complement the borrow itself, it becomes logic 0. So this is the process involved in subtraction of two 8-bit numbers. So for this answer, the difference 1 0, borrow is 0 1, as per this method. Okay, this is the manual calculation involved in the subtraction of two 8-bit binary numbers. So the same thing you will implement in the program. Let's go to the simulator. We'll start this. So whatever the process we done, that we have to implement as. So for example, we assume the data the same thing, 4200, we had that 25, then 35, output location you make 0 0. Okay, now we have to take the input, so this to be in accumulator, first data to be in accumulator, second data to be in any other register. So we'll take that LDA 4201, we are taking second data first, because we have to copy it the same to some other register. So move, for example, we'll take H register from A. I am copying second data in H register. So here no comma, only space. Okay, move H comma A. Take the first number in accumulator, LDA 4200. Now we have to clear one more register for indicating borrow. Count the borrow here, move immediate. For example, D register I am taking as borrow. So I am clearing that D register. So now we will subtract sub H. Now we will check the carry flag. Suppose no carry means no need to take 2's complement and count the borrow. So no carry means skip. The label you can give anything. Suppose carry occurs, you have to increment the borrow register. Borrow register is D here. Increment that. Then I have to take 2's complement of the answer available on accumulator. For 2's complement, we have 1's complement and 1. 1's complement instruction is complement accumulator. Then add 1 is INR A. Otherwise, you can use add immediate 0 1 also we can do. So now everything computed. Difference in accumulator, borrow in D register. We have to store the result. So here the label should be skip label STA 4202. Then take the borrow to A register, then you copy. Move A from H and store in the next memory address 4203. Then halt. So this is the program for subtraction of two 8-bit numbers. Subtraction with borrow. Okay, let's compile the program. No error. Let's take one by one the second number minus number taken and transfer to the H register. The H register is loaded in this. Take the first number in accumulator, perform the subtraction. So here F0 is there, then carry flag also 1 as per our calculation. So if it is no carry means it will skip, but carry occurs, it won't skip, it will continue this. Yeah, increment D register. Oh, I run continuously. So D register incremented. Then here I think I have given wrongly here. So here increment not from the borrow is in D register. Okay, I have taken H register again. That's why you are getting 35 as answer. So again you will complement, will take perform subtraction. You will get F0, carry flag 1, increment D, then complement accumulator, then add 1. So 1 0 is stored. Then the D register we have what D register 0 1 as borrow, that to be taken to A, that will be loaded here. So 0 1 and 1 0, that's what the answer we computed here, isn't it? 1 0 0 1. So that's all about the subtraction of two 8-bit numbers. I hope it's clear. Thank you for your listening.